So welcome students, in this question you're given that you have a 2 by 2 determinant. You have a 2 by 2 determinant made of elements 0, 1 and 2. That is, each element can be either 0, 1 or 2. So what is the probability that the determinant of that matrix will be equal to 0? So you have a 2 by 2 determinant A, B, C, D, where A can take any number out of 0, 1, 2, B can take any number 0, 1, 2, C and D can also take any one of the numbers 0, 1, 2. Now what is the probability that the determinant of this matrix is equal to 0? So you can see that the determinant is given by AD minus BC. The determinant is nothing but AD minus BC. So this has to be equal to 0. So now you know that probability is total number of favorable outputs by total number of possible outputs. So in this probability you can see that we can form a total of 81 determinants, that is 3 power 4. The first place can take 3 numbers, the second place has 3 options, the third place has 3 options, the fourth place has 3 options. So in how many ways can you fill this place and this place and this place and this place? That is 3 power 4. We have a total of 81 different determinants that can be formed. And out of these determinants, how many determinants are equal to 0? So for that, let us do the analysis. So AD minus BC has to be equal to 0. That is, AD is equal to BC. That is, the product of these two has to be same as the product of these two. So now, if you take A and D, how many different products are possible? So we know that A and D belong to 0, 1, 2. So if you take 0, 1, 2 and 0, 1, 2, and if you multiply one set with other set, how many possible products are possible? So A into D can be either 0, A into D can be equal to 0, or A into D can be equal to 1, A into D can be equal to 2, A into D can also be equal to 4. So these are the options that you have. So if you multiply A into D, you can either get 0 or 1 or 2 or 4. You have 4 different possible values of A into D. So now if AD has to be equal to BC, when AD is equal to 0, BC should also be equal to 0. When AD is 1, BC should be 1. When AD is 2, BC should be 2. When AD is 4, BC should be 4. So now, in how many ways A into D can be equal to 0? In how many ways A into D can be equal to 0? So for the product has to be 0. 0 into 0 is 0, 0 into 1, 0 into 2, 1 into 0, 2 into 0. We have 5 different ways in which the product is 0. That is 0, 0, 0, 1, 0, 2, 1, 0, 2, 0. So these are the values of A and these are the values of D. So in these 5 cases, the value of A into D is equal to 0. So similarly for BC also you have 5 options. So now in how many ways AD as well as BC can be chosen? 5 into 5, that is 25 ways. So there are 25 determinants where AD is equal to BC is equal to 0. There is this, so you can choose 5 options, next 5 options, next 5 options. You have total of 5 plus 5 plus 5 plus 5 plus 5. You have 25 options. Now if AD has to be equal to 1, if AD is equal to 1, you have only one option. A has to be equal to 1 and D has to be equal to 1, B has to be equal to 1 and C has to be equal to 1, you have only one option. Now if AD has to be equal to 2, you have 2 options, that is 1 into 2 or 2 into 1. Similarly 1 into 2 or 2 into 1. So you have combined you have 4 options. And if AD and BC has to be equal to 4, so you have only one option. If AD has to be equal to 2 among these elements, both the elements have to be 2. So that is, you have only one option. So if you combine this, if determinant has to be equal to 0, AD is equal to BC is equal to 0, or AD is equal to BC is equal to 1, or AD is equal to BC is equal to 2, or AD is equal to BC is equal to 4. So you just need to add this. So total how many options are there? 25, 30, 31. So you have 31 determinants which are equal to 0. So, the probability that the determinant is equal to 0 is equal to 31 out of 81. Thank you.